All right, we're near the end of this challenge, and this is when you get these sorts of questions that you've never seen before. There's no way that you could really like prepared for this. Um, just got to like look at it and try and think about how to deal with this. We're interested in when y takes its maximum possible value, and then what expression is equal to y minus x. And we have four integers. X and y are variables, p and q are constants. Wow, a good shout is to try and make y the subject of this equation. So it's going to be, I'm going to change it to y x minus, um, actually, I don't know why I did that. Let's keep it as xy minus qy is equal to px. I've got y on one side now because I can now factorize it. X minus q times y is equal to px. So y is equal to px over x minus q. Right, I've made y the subject. Let's not forget, sorry, they're all integers, okay? That's going to be actually quite crucial. And we're interested in finding this maximum value of y. Well, there's a little trick we can now do that it's worth, if you're not aware of this, then learn it now, basically. We can, first of all, we can get rid of that p, we can bring it down and times by it afterwards. Problem is I've got x on the top and x on the bottom. Like it'd be easier to deal with if I just had x on the top or the bottom. But what I can do is the following. I can write this as x minus q plus q. Okay, so I've not changed it. And then I can separate it into two fractions. It's going to be p times x minus q over x minus q plus q over x minus q. And what I've managed to do is get it so I don't have x in the top and bottom. I've simply got it in the bottom. Because now we come back to the fact that x and y are integers and so on. So I am dividing by something, and I want to make y as big as possible. So I want to divide by something that's as small as possible, essentially. But I can't divide by 0. That's not going to be any good. But the bigger x gets, like if I divide by 100, then this is going to be small. So actually, to maximize y, I can set x equal to q plus 1, because then I'm simply dividing by 1. That's the smallest positive integer that I can divide by. And here, y will equal p times 1 plus q. And therefore, when y is its maximum possible value, y minus x is going to equal p plus pq. I've just expanded this, and then I need to minus my x, so I'm going to minus q plus 1, which is the same as minus q minus 1. And that's going to be my answer, except all these are factorized. Okay, except that one, which is clearly not. So I could either expand each of these and see which one is the same as mine, but it's going to be quicker to actually just factorize it, I think. P in Q we're going to need to get PQ. I need a minus Q, so that's needs minus 1 here and a plus 1 here. So you can see I'm going to get PQ plus P minus Q minus 1. So it's P minus 1, Q plus 1, which is this one here. Okay, I think that is a challenging question if you've never seen anything like that before. But you know, I hope you're doing okay. Keep going with this.